Well, this is to kind of talk about one of my favorite projects this last fall, and that's adding heat to my greenhouse. We've been through some already cold temperatures here. I think the coldest we've had so far is 15 degrees below Fahrenheit. And prior years, my greenhouse would be dead. I mean, I'd have to move the lettuce inside, but they're in little trays anyway. But my hydroponics, where I have my peppers and tomatoes, they'd just be, it'd be over with. But this year I had an idea. Once I got my little chimenea put together, I thought, hey, I can build myself a little ammo box stove just to see if it might add enough heat. And sure enough, this thing has actually gone through a 15 below night now, 15-degree Fahrenheit night below. And I still have tomatoes and I still have peppers, and it's been great. I'm just going to talk about some of the steps I went through because it's working well. It's got some pretty sophisticated stuff when it comes to using the outside air and how I control that, and also heat storage as well. So let's just get right into this here too. And this is where it's all about. These pictures were taken the first week of January, a couple of weeks ago, after that 15 below night we had. These are some red mushroom peppers, very hot. Back in the background here, that's some giant Marconis. Those are Livingston Ideals, black cherries down here, and then I had a couple leftover petunias in this pot last summer. I thought, oh, I'll put them in here, and they were like dead, but I guess they weren't. But that is just a great place. I mean, in fact, sometimes I kind of walk out in the wintertime with a whole basket of salad fixing stuff and just almost giggling because it's like middle of the winter and here I'm having this wonderful bounty. So I cannot say how much I've been enjoying this greenhouse. It's been wonderful. Um, so this is what I came up with. I had a bunch of these. I ran across a guy several years ago. They had a bunch of these larger, I think they're 20 millimeter ammo cans. I don't have the exact whatever it is, but they're 17.5 inches long, 14 inches tall, and 8 inches wide. And on top of that, I welded a 3-inch exhaust pipe. I went to my local auto parts store and got one of these little repair kits, and I use this 3-inch exhaust to my 3-inch pipe, and it fits together really well. Although I found out you do have to use, I used the glue that came with the heat shield fiber around the door because the 3-inch pipes don't really fit very well because they're not really put them together. They're kind of D-shaped, and sometimes you get gaps in them. So I found out using this kind of heat cement really sealed them up well. I know next time I take it down or adjust it, I'll have to kind of reapply the stuff. It gets really brittle. But I also did not add legs to mine. I'm not sure how long this ammo box is going to last until it burns out. This is why I designed it this way or built it this way, because the top can be taken off and then just added to the next one. The door behind this little hinge door here, I just used my plasma torch. In fact, this was the very first thing I used my torch for, and it was right then and there I realized I'm terrible at freehanding with my plasma torch. I was just all over. It's not square; it's more like a polygon. I got this metal from a Rockwell Collins industrial surplus, and I don't know what it is, but I ruined a couple drill bits trying to drill these large holes until I realized plasma torch time, and I kind of blew out the back here. The top round disc, that's just aluminum. I can just turn and close them off, and I'm really feel lucky that I balanced it by the air intake and air outtake so well that yeah, I can just close it right off. But also having all these vents completely open is just perfect. I kind of like how this thing works. Like I said, the legs don't exist. I just built a base. That way I can set the new one right on top of the base so I don't have to rebuild everything. I'll go through the rest of this here, but you can see what I did. I just cut a little section off here, hacksaw, and a piece of aluminum with a little notch in the side, which would kind of lock it in place. There is one piece of heat tape, real thin heat tape fiber stuff at the door behind it, just sealing it up. And these wires here in the top, I just put them on because I got tired of lifting the handle up to close the door all the time. It just was a little bit tight there. Um, Now I did see here. This is a mistake I made. Originally, when I first put this thing together, I had removed the metal lining because I needed to weld the exhaust pipe here to it. And I also, of course, got rid of the rubber gasket and replaced that with a fiber gasket for the fireproof doors. And it was just really went together perfect, and pinched that fiber, and I thought, great, it's going to be there forever. Well, it won't. And as you can see here, when this metal heats up, it expands. And of course, where is it going to expand? Well, it expanded inward, and I would get some leakage at the top here in the middle. So what I did, I kind of retrofitted this. I put these bolts, I got some stainless steel bolts here, drilled holes through here, and then underneath this lip, I put another thinner piece of the fiber door heat material in there, kind of wedged it up as high as I could, and then tightened it all down on top of that. And so it kind of pinched the two pieces of metal together, pinching that fiber heat tape, and that solved the problem. So I would definitely recommend doing that if you do the top like I did. I can see other people did turn it over and weld on the bottom, and I don't know, I might have been ahead of doing that, but we'll see. Maybe the next one I will do. Um, I did put some heat. I filled this tubing full of sand and bent it around a piece of pipe I'm circulating water through it. I have a 55-gallon tank of water in my greenhouse, which I just use for heat storage. But now I'm heating the heat storage through this tank here. And what you see down here, those are little fins. That's just a little aluminum flashing I bent around here and clipped them on the heat because the the, the fluid goes through so fast. I got a pretty almost too big of a pump, and you can touch the pipe and see there's a little difference here, but boy, yeah, it really goes through pretty quickly. So I actually added those fins just to capture some of the radiant heat off that, and it does get hot. In fact, when stove is going, you do not want to grab these fins because they are hot. Um, let's see here. Next one is this is another mistake that I knew I was making at the time. I put a 90-degree on the outside here, and I knew I needed a T with a clean out. But at the time, winter was coming. I don't know if I couldn't get one, or I just figured I'm going to add this on next year and try it this year. And sure enough, within 2 months of using this, I've already had to clean it out once. I do have a long run here. Basically, it's around, I don't know, 14 or so feet total when it comes to from the stove all the way to the top here. And also the roof back here, even though this is below the roof, it's just the way my house is. This roof is stone coated steel, so I don't think there's too much of a problem with the fire damage here in the stone house and everything. So, and I made my own thimble. I think that's what it's called when pipes go through a wall here. Is that what you're looking here is aluminum flashing. I put a piece of aluminum on the inside, and there's also aluminum on the outside. But I did not stick them, laminate them together, touching. I put, again, some of that fireproof gasket material between them. I used some of that high temperature caulk, kind of to caulk them both together. And so there's an air space in between them for extra insulation. The tubing here, that's a larger size. Again, this is 3-inch stovepipe, single wall running through that. And there's also a larger metal tube that forms the thimble that goes all the way through the entire wall there. There is a little gap between the two because there's two starters I used, and I put them together with some insulation. And I pack that with, again, more of the heat tape, the door gasket material, just to kind of keep it centered and make sure it wasn't going to get too crazy. The outside material here, again, that's just more of aluminum flashing to keep the rain off of that, because it's not really sealed up well at the very end there. It's not been a problem. So um, the whole the whole thing that attaches it, I just welded up some tabs. I repaired these windows last year. I never really had good quality windows up here, and so I made these aluminum frames, and I put in this twin wall polycarbonate. Holds up very, very well. Um, and instead of putting, of course, polycarbonate in here, I just cut the aluminum for the right size for the frame, and it's all caulked in the other side. and it's been holding up real well. Yeah, I had to get kind of creative on the attachments here when it comes to holding the pipe in place. But we had one terrific storm here about, oh, I don't know, had to be about a month or so ago. We had some 50-mile-an-hour winds and had absolutely no problem. So yeah, I'm kind of happy with it. Um, Now, the problem I was talking about with filling up this 90 right here, oops, too far, was filling up the 90 right here, is that I noticed that the draw was kind of decreasing. I thought, well, I got to get up there, take a look, and of course, a flashlight in that tube. I couldn't see any light coming to the top, so I knew it was kind of plugged. But that flashlight was like, in a coal mine at midnight. You couldn't see anything anyway, and I did not want to use my shop vac because that just would kind of fill the whole greenhouse up, and I didn't want to use it at the top of a ladder outside. So I tried. I got my leaf blower out, and I climbed up the ladder inside the greenhouse and took off that 90 on the inside and put the leaf blower right on the 3-inch pipe, and the two would just fit perfect. I turned that thing on, and it was just I could see a cloud of black outside from the greenhouse, and here's what the snow looked like. But what you don't capture is about the 12-foot circle of where this all the, and it was just perfect. It worked perfect. It was just clean as can be. And I did the same thing. I took the lower pipe out, took that back, and it was not near as dramatic, but yeah, that was a simple way of doing it too. And again, I found a heat gasket cement when assembling a stovepipe. Like I said, the stovepipes, these small diameters are more of a D shape than a really a round shape because of the way they're just so small to put together good. And that actually worked real well. I know every time I reassemble it or disassemble it, I'll have to reapply that gasket material. So now, this is the aluminum heat shield I put on here because right on the right side of that is actually one of my pepper plants, and that would probably be cooking it. I did not want that, but that's also where I added my heat sensor here. This is the temperature sensor, TMP36. I know a lot of people don't like using them because, well, they are erratic. They're analog and they jump around a lot, but on my software, I use an Arduino to control everything, and when it takes a reading, it averages 64 readings. And that gives you a pretty darn consistent number there too. So it's not been jumping around. I like that a lot. Makes it real simple to interface to. Um, this is the controller I use. It says fogger on here because I was using this for a Martha mushroom tent to control the misting, and I actually had a couple extra of these. And I was thinking, well, I need something to control this device in the greenhouse, so I just repurposed one of these things, reprogram it. The top part, the counting and timers don't do a thing out here. It's really only the bottom section, and these are these Nexion displays I really like. A couple years ago, if I was doing this, I probably have buttons to push, and then button here and a button up and button down. But now I can just slide my finger back and forth and change the parameters very easy. In fact, what this 61, that's the temperature from the temperature sensor on the heat shield. 79, that's the set temperature. And I can control that by just dragging this bar back and forth here too. And this should tell you if it's armed, on, or off. The whole thing inside here is a Arduino computer. And that has a servo control for my blast shield, I'll tell you, as well as controlling a solid state relay for the fan. I'm using a 110 AC fan on this thing. I just plug into that, turns it off and on. This is the logic of this particular thing. This is the video I will show you in a second. But what this does, when you first turn it on, it opens the gate up and turns the fan on. And the reason the fan turning on at this stage is that the greenhouse is pretty tight. And I want to make sure that the air is going out and not back in when I'm lighting the fire. Because sometimes I've noticed I had problems of the draft coming down. So turning the fan on helps to pressurize the greenhouse a wee bit. And so it will actually start drawing out. Then that temperature sensor, when it reaches the threshold, it actually opens and closes and turns, doesn't really do a thing. It just kind of lets me know it's been active by closing and then reopening again. And then it'll be on. And then if the temperature ever falls below that set temperature, it shuts it all off. The blast gate shuts down and the fan also turns off. Now, I played around with the fan here a little bit. turning off and on, having it turn on to pressurize and then turning off, but I don't know. Right now it still just runs continuously until the whole thing shuts off. This is it in action right here. So it's 3D printed. It will actually open and close based on the temperature in the greenhouse, and also the solid-state relay then turns the fan off and on. Now, I did not design this blast gate. Thank you for Tail Slide. I got this from Thingiverse. Just if you search there for blast gate, there's a link to it if you can actually just copy it off the screen. And thank you, Tail Slide. It was a wonderful device. Worked really nice. The only complication I had was actually interfacing my servo horn to it. I had to kind of modify one and epoxy it in place. It was kind of a strange size he had, but it's working fantastic. I did have to print up and design a little interface to that though. I use these little muffin fans, and it just fits right into the blast gate. It's really just a friction fit even. And I use a lot of these things, and I'll go ahead and post these things to Thingiverse as well on my channel, OT and AT here, ASAPC. Anyway, I use this loop. What you're seeing here, this is the U.S. solar pump I use. This is what circulates the water to a 55 to gallon heat storage jug here. But what you're looking at here, I think I showed this a little bit later here too, this pump is not priming. It's not self-priming. So what I do, I pour water into this particular vessel, which is nothing more than a palm jug inverted. I have a little fitting to it. I turn on this pump down here, you have a hard time seeing, and then that will just charge the whole system. And then once I get that system charged up and running, I'll plug the other pump in, and it'll continue to run until I unplug it. Now, to get the air from my outside, this is a dryer vent. I use this 4-inch dryer vent. Lots of fittings for out there, aluminum type of fittings and all sorts of things for dryer vents. So this is the outside of my greenhouse. This is not louvered with adjustable louvers. It's just completely open all the time. A lot of dryers have a little swing vent for backflow. This one does not. I did not want one because I'm going in, not out. Prior to my insulating this is what the aluminum pipes look like running to it. And I did insulate the entire pipe and tube because I did not want this below zero temperature tube running right inside of my greenhouse, cooling off the greenhouse. And I did not insulate the very end because, again, this whole thing just dumps all the air right at my stove. And that's why I'm burning cold, dry outside air in my stove, in theory, instead of actually sucking from every corner of the greenhouse and then basically drying or using up my moist air in the greenhouse. So I have to say it's been working terrific. So this is how I use the plumbing. Again, I talked about I used this, filled the copper tube with fine sand, bent it around a tube, knocked all the sand out, cleaned it out, soldered everything. Down here you see these little fins. These are aluminum flashing that I found a way I can just bend them so I can snap them right on a 1/2-inch tubing, because I was not really getting the delta, the heating up the water I want. The water kind of zips through so quickly. So I added these things to the tube, and these things get so hot you cannot touch them because they're very close to the side of the stove. And also, my U.S. solar pump here too is actually pumping cooler water out of the tank and then pumping the return line back to it. So there is a valve right here. I should have mentioned that before. I open that valve up, and when I'm charging the whole system, turn the valve off then. That works. This is the U.S. solar pump. Again, these things can run 24/7. I've used this in my chicken coop for my solar thermal loop. Works fantastic. Here's a little bit better picture of my charging pump. This one makes a little bit more noise than I want. This solar pump, you got to almost feel it to hear it and to know if it's running or not. These are really well designed. But yeah, I think this is a real good system. I do intend to make some changes. I want to put some more aluminum flashing here just for fins, and I also want a little vertical one here because when you're standing right here in front of that, you can feel the air coming around, wrapping around, and there's a little air coming out here. So I think I want to put a little 90-degree here so it hits that and kind of directs it back to the stove again. So I'm burning, the colder air. The heat tank itself, yeah, I mean, if I'm really using this and using it for a day, I can get 70 some degrees in that heat tank. And I have about a 2 foot, I got one of these probe um, thermometers I got at some ham radio fest many years ago. So it's measuring not just the very top, it's measuring about almost 2 foot down. So I'm getting a pretty good heat storage. And it does not shut off, of course, with the fan and the blast gate. It just keeps on running. So also, once I get the heat storage, in theory, I think it's actually coming back off and just rotating through this whole fan assembly here and actually giving up its heat, which I want it to do. It's more like a thermal well or energy well back and forth. So, but this is the reason why I'm doing these things. I wish you luck if you have your own little greenhouse going on. Um, I have the best salads in January from my greenhouse. I cannot say enough of how well this has been working. So, anyway, I hope this helps. Enjoy.